although people often point to the idea that, well, we've just got an N of 1 when it comes to Earth and observing life, what you've pointed out there, quite right, is no, we have more than just N equals 1. We also have time constraints as well. And those time constraints make a lot of difference about inferring whether or not...
Right, so we do have an N of 1, but we also, as you point out, we have information on the timing of that N of 1.
So it might very well still be the case for the optimists that, if they're optimists about wanting there to be aliens out there, there could be alien bacteria out there. What are the chances of alien multicellular organisms, alien vertebrates or something like that?
Or you could also ask, what's the probability of alien viruses? So we just talked about the origin of life and that you can get a rough handle on it, the estimate of how probable it is based on how quickly it evolved on Earth. As to what happens after that, I just wave my hands. And the reason I wave, this is a very important point, because you mentioned earlier that, I think you said flight, and many people, Richard Dawkins and many others, including Simon Conway Morris, have made the point that, there are many examples in the history of evolution on Earth in which there has been convergence on certain traits. And I've been pushing back on this for about 20 years. And the reason I push back is because of what I call deep homology. So what I mean by that is, so you will see Richard Dawkins, probably in 10 of his books, he says their vision has evolved multiple times, or the eye, or eyes have evolved multiple times. And I've heard that repeated hundreds of times, and I think it's just wrong. The reason I think it's wrong is the following. He talks about vertebrate and invertebrate eyes, okay? And he says, look at that, that's an independent origin. But like all life on Earth, they have common ancestors. You and I have a common ancestor maybe 10 generations, maybe 20 generations ago. We and chimpanzees have a common ancestor about 6 or 7 million years ago. Now, you can ask the question, when was the common ancestor of vertebrates with this vertebrate eye and invertebrates with this supposedly independent eye? And the answer is something like 600 million, maybe 500 million years. And then you have to ask the question, did that common ancestor have anything that looked like an eye? And the answer is yes. It had what you could call proto-eyes or proto-proto-eyes. So when you say it evolved independently, you're pretending that you don't have a common ancestor which had the prerequisites and a lot of the basic ingredients, including the basic biochemistry that octopus eyes and our eyes currently have. So that's I'm invoking what's called deep homology, deep common ancestry, that you need to know about what was already there before you talk about convergence. Another short way to say it is everybody has a common ancestor. And if you want to talk about convergence, you have to talk about divergence. If you want to talk about divergence, you have to know how similar, what fraction of the trait you're converging on was already down here. That aspect is the crucial part of this argument, and it is systematically ignored by all people who are talking about convergence on flight, convergence on eyes. We talk about flight, for example. Let's talk about flight. Flight. What is birds and bats? Bats are mammals. Birds are reptiles. They evolved from reptiles. They have a common ancestor about 340 million years ago. The question is, did the common ancestor have flight? Well, not really, but it did have 4 legs. Birds go like this with their front legs, and bats do the same thing with their front legs. So obviously the ability to go like this was in the common ancestor of bats and birds. So that's another example of one of the more fundamental aspects of the trait you're talking about was already in the common ancestor. And that's why I keep on invoking, you have to talk about what was in the common ancestor before you talk about convergence. So deep homology is usually ignored, and convergence is always, it's wonderful, it's converging on the same thing. Another example. Here's another example. Dolphins and humans. We have big brains. Dolphins have big brains. But we know that our common ancestor with dolphins was more like a cow-like thing. And this would have been 95 million years ago. We know these timings from the genetic proximities to each other. And so here we start out a creature. Now, let's say here's 4 billion years ago, and here's today. We have a common ancestor with dolphins 95 million years ago. That's less than the thickness of my finger up here. So we were identicals, evolving all kinds of the same gene hierarchies, the same organs, the same eyes, the same bilateral symmetry. And then 95 million years ago, we diverged. Now, although the common ancestor had a small brain, we know that the things that regulate how big your ears are, big your chin is, or big your heart is, or small, those are things that have turned into toggle switches that you have the same gene regulatory networks that the dolphins have. So you flip a switch very easily, and then, oh, your nose gets bigger, or your brain gets bigger. And so that's not convergence on something. It's a result of an identical system of wiring that evolved during 4 billion years minus 95 million. So that's that thickness of so it's a little like another example would be, identical twins. Let's say two twins are born, and let's say they grow up as carpenters and they get taught the same things, and then suppose then at the age of 15 they're separated for 3 years. And then you find out, oh my gosh, they've been separated. They've converged on the same type of cabinet. And so, well, of course they have, because they had for 4 billion years, for the first part of their lifetimes, they were identical twins with the same genes and the same environment, and that sets you up to be able to produce many of the same things that, although they might not be there when they were separated, they converged on it only because of these prerequisites and deep homology. That would be my argument against the invocation of convergence that seems to be in style among most biologists today.